Young people, welcome back. BNB, here to help you out. Let's see what we got, guys. Chapter 6, Lesson 6. Learning objective. Solve system of linear equations by graphing. Second objective. Apply systems of linear inequalities. Got it. Students will be able to graph systems of linear inequalities. The concept is linear inequalities, and the skill is graphing to solve them. Before we get started, though, there's going to be a thing that happens in this handout that's going to happen over and over. 4 questions. And the thing is this: we've graphed lines before, and we always wanted to use slope-by-intercept form. What's the M? What's the B? Boom, got it. Second, we've already graphed inequalities. We graphed inequalities in a single variable. So in other words, on a number line, right? And on a number line, we had to decide, are we going to shade to the right or are we going to shade to the left? And we also had to decide where to begin. And lastly, we had to decide, was it going to be a closed circle or an open circle? So listen to me closely, because I give this to my students and then I put it on the board and I leave it there and I ask them to remember it. But we make charts, we write it over and over. But guys, remember, it's always 4 questions when doing systems of inequalities. What's the M? What's the B? Do I shade above or below? And is it a solid or dashed line? So as we go through this, guys, you're going to hear me say that multiple times. Let's get this bad boy started. Yowzer! Nice looking handouts. Graphs all over that thing. Yes, because we'll be graphing all day long. Systems of inequalities, guys. I'm loving the first 3. And the reason why is it looks like 1, 2, and 3 are single variable. Meaning, I'm going to either have a horizontal line or a vertical line, depending on the X or the Y, right? So, number 1, where I think it's pretty straightforward, guys. X is greater than -1. If it said X equaled -1, you would have a straight line. Straight line. Where X equals -1. But it's an inequality. And that's why it's a dashed line. Now, the second thing I'm doing now, guys, is shading. Now, hopefully you came to this video and you know why I'm shading. Everything to the right of that dotted line is what X can be. X can't be anything else. So that's why it's a dashed line. Since it's not equal to, it's a dotted line, not equal to. Now, Y is less than or equal to -3. First of all, solid line. Why is it solid? Because it's equal to. Straight solid line, because it's equal to. And of course, now am I going to shade above or below? Well, guys, since it's less than, I'm going to shade below. You're going to hear me say that so many times throughout this video. All right? So, the first equation of my system of inequalities, 2 or more inequalities, I had a solid line. I'm sorry, a dashed line. The second one I had a solid line. So the solution is a double shaded area. Yeah. And again, this is something that we're going to be doing over and over and over. Double shaded area. So again, horizontal line, because where does Y equal to? Right there. But all the way across. Dashed line, because the inequality is not equal to. And of course, what would be greater than 2? 3, 4, 5. So we shade above. We shade everything above it. Right? Everything above it. Now, that's only one inequality that we graphed. We got to graph the second inequality. The second inequality says X is less than -2. Well, where is -2 on the X axis? Right there, right? Now, where else is it -2? There, and there, and there, and there. So again, guys, anywhere, that's kind of what we call a boundary line. So, there's a ton of vocabulary out there. I'm going to mention boundary line again. And when we graphed inequalities the first time, we only had one graph and we just shaded one side. Well, now we're double shaded area, right? So in this situation, guys, after I graph the second inequality, I'm going to recognize what is my solution. My solution is the double shaded area, right? So I'm going to go ahead and use a different technique to show the solution to the system of inequalities. Next one, finally I have a slope-intercept form. Y is greater than x plus 3. Or in other words, y will be equal to x plus 3. Treat it like a line, right? I start at 3, up 1 to the right one, do the opposite, down 1, back 1, down 1, back 1, down 1, back 1. So this is where I was talking about, guys. What's your M, what's your B? Use that to graph your boundary line. Now that you got your boundary line, is it a dashed line or a solid line? Well, guys, dashed because it's not equal to. And I'm choosing to shade above because the inequality tells me to shade above. As long as it's in slope-intercept form, you're going to see me do it over and over, guys. Y equals mx plus b. If it doesn't look like that, I'm going to put it in that form. I want it to say y equals. So in this case, y is greater than, y is less than. So even in the next one, y is less than negative, y is less than or equal to negative 1. I chose where negative 1 is for y, axis. And then of course here's that straight line again because I got to treat it as a single variable linear equation. Now again, guys, it's a solid line because it's equal to. Notice inequality 1 was greater than, inequality 2 is less than or equal to. So since it's equal to, make sure it's a solid line. Bam. Where do I shade though? What makes it true? Below the boundary line or above the boundary line, right? Well, everything below the boundary line is less than. So yes, everything less than that boundary line. Guys, I have a double shaded area. It is right there. And that would be the solution. So what's incredible about this, guys, is you're not writing a coordinate point, you're not putting x equals. You cannot solve these inequalities unless you do graph them because you're showing the solution on the graph, right? So systems of inequalities, double shaded area. Let's get to it, right? 4, 5, and 6, looks like 4 is starting us off how we left off. X is less than 2. Therefore, I'm thinking that's a single variable. Well, I need to find out where to begin. I'm going to begin where the number tells me to begin, 2. And since it's less than and not equal to, I'm going to keep a dotted line where x equals 2. Because if I had to graph x equals 2, well, x is equal to everywhere right there. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, so everywhere. That's why up and down, you got that. And again, guys, since it's less than, what's less than 2? 1, 0, negative 1, so I shade the whole entire side of it. Dotted line, or dash, you'll hear me say both. Dashed line, shaded to the left or shaded below. I like below because it's less than. Now the problem here though, guys, is it doesn't say y equals mx plus b, so I converted it into the proper form. Now with the proper form, guys, I got a b, I got an m. I'm treating it like y equals mx plus b. You see it, you got it. What's my m, what's my b? Here we go. I want to shade below, and it's going to be a solid line. Yeah, not close. Close would be if it was on a number line. We're doing it on a coordinate plane, so a solid line. So guys, I'm going to graph my boundary line. And the boundary line is basically the line that I see. I just need to understand it's an inequality. So I started at 2, did that slope, up 1 to the right one, did the opposite, down 1, back 1. And of course, solid or dashed line, we already said it's solid because it's equal to. So I get a straight edge, put my arrows on the end. And again, guys, is everything above the line true? Or is everything below the line true? Right? So the inequality tells me, since it's less than, everything below that boundary line is true for that inequality. And of course, guys, we can do a test point. If you don't remember what a test point is, we pick a point on the coordinate plane. Usually it's 0, 0. And we find out if it's true or false. If it's true, that's the shaded area. If it's false, that's not the shaded area. We shade the other area. But do you see your double shaded area here, guys? You should. You see where it's also blue and green together, and that is what we would call the solution to the system of inequalities. Bam. Love it. What I'm not loving is number 5. Because 5 is in standard form for the first equation, standard form for the second equation. And if you're not clear on that vocabulary, standard form, ax plus by equals c. In this case, x plus y is less than or equal to negative 1. Get rid of the x term, and I have what I like. Y equals. By subtracting x from the left side and subtracting it from the right side, y is less than or equal to negative 1x minus 1. Now I got an m and a b. M is negative 1, b is negative 1. Ask the next 2 questions, do I shade above or below, and is it a solid or dashed line? Guys, I get that like that. I'm gonna have to get a pause here in a second to make sure I clarify what's going on. But we started at negative 1, we went down 1, back 1, down 1, back 1, down 1, back 1. That's graphing a line, in this case, graphing inequality, linear inequality. Did the opposite with up and back, up and back, up and back. So it does look like a straight line. And this is where the S/D comes from. Will it be solid or dashed? Well, solid because it's equal to. As long as there's a line underneath the inequality, it's a solid line. If there's no line under the inequality, it's a dashed line. And again, A or B, above or below. Well, the inequality tells me below. Everything below. Well, I guess I'm not going to shade. Move on to the next one that fast. All right, we'll shade later. X plus y is greater than or equal to 3. When I subtract x from both sides, guys, guess what? I'm ready. Y is greater than or equal to negative 1x plus 3. And again, guys, m and b. So we're doing the same thing we did when we graphed linear equations. That's why it's an old skill but a new skill. And then we have those 2 questions, above or below, solid or dashed. Well, above because it's greater than, and solid because it's equal to. You see me getting my slope. Started at positive 3, went down to the right, down to the right, down because it's negative, right? Then did the opposite, gotta get a straight edge, and again, solid, right? Because it's equal to. Now here's where, again, I did not shade the first inequality, so I'm gonna have to take care of that. But it looks like for the second inequality, got the arrows, that looks good. But for the second inequality, the one that read x plus y is greater than or equal to 3, we changed to x is greater than or equal to negative 1x plus 3, we shaded both. And then of course for the original, the first one, there we go, we had to shade both. So this, guys, guess what? Where is the double shaded area? There is no double shaded area. All right, so there is no solution that's going to work for this. This could be considered one of your no solutions, right? Because just like when we did solve systems by graphing, where they intersect with the solution, and if they were parallel, there was no solution. Well, guess what? These are parallel. We have no solution. Wow, was I done? I don't think so. No, I guess I called myself done. But we got plenty more to do, guys. Number 7, first equation, y is greater than x plus 1. I'm loving that because I see the m and I see the b. Wrote my m as rise over run, and b, we get 1. Now the above and dash. Above because it's greater than. Dash because it's not equal to. So I'm answering those questions because I know the answer. If you don't know, then I can tell you. I'll tell you on the next one. We're shading above because it's greater than. Everything greater than y, or greater than the boundary line, right? But for the second one, guys, y is greater than or equal to negative 1x plus 1. Again, I love it because it's in the form that I need. And guys, here's where my pause is going to go. As it stops right before I write solid, it's a solid line because it's equal to. If I say you have less than $3, do you have $3? You have less than $3. You have $2.99 maybe. That's not $3. So you can't say you have $3. It's not equal to. So hence an open circle because you didn't have $3. But if I said he has less than or equal to $3, now I would close the circle because it's equal to. So now that we have a linear inequality, we're not talking about an open or closed circle. We're talking about a dashed line or a solid line. So it's solid because it includes the points on the line. Meaning 2 plus 2, x plus y. If it said x plus y is greater than 4, is 2 plus 2 greater than 4? No. 2 plus 2 equals 4, but 2 plus 2 is not greater than 4. So don't make that line solid because that coordinate 2, 2 doesn't work. When x is 2 and y is 2, it's not greater than 4. But the minute I say x plus y is greater than or equal to 4, now that line becomes solid. So just remember, line underneath, solid line. No line underneath, dotted line. Let's get back started. All right, guys. Where do I begin? At 1. Boom. Look at that little red. And how I move down and to the right. Rise, run, rise, run, rise, run, rise, run. Rise, run, rise, run, rise, run. Solid line. So guys, again, sometimes you gotta wait for me to get my straight edge. And here it comes. And solid as a rock. Here we go, guys. Shade above it. So let me get a little. And then, guys, easy to see my double shaded area. But let's remember, do anything else to indicate the double shaded area, or is it double blue? And what's cool is all those years of teaching and seeing all the different ways that students indicated the double shaded area, right? And we got it. So let's keep it moving, guys. So for number 8, as I believe we're moving on to number 8. I look at equation 1, and I look at equation 2, and I give it 2 thumbs up. One for the first equation, one for the second equation. The first equation, y equals mx plus b. Y is less than 2x plus 4. What's my m? What's my b? Secondly, am I going to say it above or below, or is it going to be solid or dashed? The inequality tells me below and dashed. It's not equal to, and it's less than. Now, it takes a look at the second equation. Again, m is staring at me, b is staring at me. The inequality answers my second 2 questions. So when I started the video, guys, remember I said the same thing right now. I had 4 questions. What's the m, what's the b, above, below, solid or dashed. Now you see it, you get it done, all right? Let's graph it. We're going to begin at 4. I guess that is the one. Did I skip 8? I don't know, whatever. So, start at 4, go down 2, back 1. Because if I started at 4, I can't go up 2 and to the right 1, unless I have no space. So do the opposite. Down 2, back 1, down 2, back 1, down 2, back 1. As many as I can. And then, of course, there's my solid line, new dashed line, because it's not equal to. And then what I like to say, guys, why is that below? Because you always think about a little guy, like Mr. Minecraft, the little Minecraft guy, he's pulling out every once in a while. He'll walk up to that line, he'll hit the bottom of it, and he'll walk up it. So it's actually below, right? Sometimes kids get confused on above and below, even though they know you're supposed to shade below, they mess up. Don't mess up. All right, second one, we started at 1, and I've already got all my points from my slope. My slope of 1 just meant up 1, right 1, up 1, right 1. And of course the opposite, down 1, back 1, down 1, back 1. And this is a dashed line. No, it's solid because it's equal to. And again, above or below, we already know because we already underlined the A. And see how this time guys I'm going this direction? Because in the other one I went in that direction. So it kind of shows a crisscross. Like a little crisscross. It's easier to see a double shaded area. Especially if you use a beautiful green highlight. Beautiful green highlight. Alright guys. Looks like I took care of 7 and 9. I don't know why we skipped 8. Probably just for room and time purposes, right? And let's go ahead and get some room. And let's see what's next. Alright guys, well this time we're going to write the system. And this is probably using the reverse technique. When I say the reverse technique, I can write what I see. I can find M, and I can find B. Y equals mx plus B. But knowing I'm going to use an inequality. It's going to be less than, it's going to be greater than. And again, by seeing that it's shaded below the line, I know it's less than. To see like for number 11, it's dashed, I know it's not equal to. So right now, I'm getting my y-intercept, 2. And it looks like I'm up 1, right 1. So the slope's 1. So I already know it's y not equals, because this is a solid line shaded below. Y is less than or equal to 1x plus b. So again, those 4 questions we're using again. Since they're showing me the graph, I'm going to pull those information I need to write what I need. So on the second one, where did it begin? How did it move? Well, same thing, went up 1 to the right 1, so my slope was 1, and also it started at -3. So y equals 1x minus 3, but it's not equal, it's an inequality. So it's a solid line and it's shaded above. So that's got to be greater than with the equal to. And that's all there, guys. Whoa, whoa, whoa. Oh yeah, that's right. I'm good. Boom, bang, pow. And that's just my way of showing there's my new system of inequalities. All right, guys, for the next one, number 11, nothing's changing. I do see that they share what's called a y-intercept. They share their y-intercept at the origin. So right there in the middle, you see where the 2 lines cross, right? Well, that's also where they cross the y-axis. So b is 0, not just for one of them, but for both of them. But one line seems to be going downhill, and then one seems to be going uphill, so I got one slope that's positive going up. Yep. I got one slope that's negative going down. Yep. To the right one, down one. To the right one, down one. So -1 over a positive 1 or just -1, right? So there's my M and B. Y equals mx plus B. Take away the equal sign and replace it with an inequality that needs to be dashed. And for the red, it looks like they shaded above. So I'm looking for greater than. And guess what? For the blue, it also looks like they shaded above. So since they're both above, they both have to be greater than. Now I've got all the information that I need. Let me start writing the actual system of inequality. Y is greater than 1x, or just x. Oh, I'm doing the blue first, my bad. Y is greater than -1x. And no need to put plus 0. And y is greater than positive 1x. And again, no need to put 0. So, and looks like 12, as we move on, has a single variable. Remember those? So, I got a dashed line, horizontal, going straight across, right? Straight across, dash, horizontal line. So, y equals, sorry, we're doing the other line first. Y is equal to 1x plus 0. Y is plus 0. That y-intercept is not 0, y'all. Whoa.
Oops.
Guys, my editor is going to give me, well, you know, I average one a video, but that's all right. Moving too fast. My eyes slipped on me. I wanted to say 1 for that red, but hey, maybe I'll catch it. But guys, again, looking good. Solid line, which means it's equal to, and it's shaded above, right? So the only thing that I would like to fix there is change that 0 to a 1, and I'll feel good about y is greater than or equal to 1x plus 1. All right, and then of course the next one, this is what I mean by, you know, it's dashed and it's shaded below, so it's where y is equal to 1, but we're not talking equations, we're talking inequalities, so let's go ahead and state it as, yeah, there we go. My bad. So, got it. We finish the last of it? Let's see. Okay, guys, I'm feeling good. I hope you are too. It's lovely that I was able to go back and catch that mistake. You're not going to catch all the mistakes that you're going to make in your math class, your history class, your science class, college, life, period. But the fact that you can learn from them is what makes you a better person. Guys, thanks for watching. Appreciate it. Can't wait to see you on the next one.